Hello everyone. In the previous video, we made the AI follow the track path, and we also made it move backward when it encounters an obstacle in front of it, such as a wall, or when it gets stuck in front of something and cannot move forward, it reverses. Today, in this final video, we will make the AI overtake obstacles in front of it, as well as other cars, as we will control its reactions and speed. So without further delay, this will be another creative and easy video. Let's begin. So let's go to the AI car to create a new custom event while I explain what we are going to do. Simply put, we want to check whether the path in front of the car is clear or contains something. Of course, we can't do this in the usual way because we need the trace we'll create to follow the path and its rotation as well. And that's the main idea behind what we'll be doing. We'll use sphere trace for object. I'll set its value to 120 for now and make it a variable. For the start point from the spline path, I'll use getDistance@Location, then location@Spline, then getTangent@Distance, the same method we used in the previous video. Before connecting it to the start point, I want to raise it slightly on the z-axis, which I'll also make a variable. As for the endpoint, I'll use normalize, then multiply it by a new float variable that determines how far the trace checks ahead on the path. We'll combine them and connect them here. In the object type, we'll use makeArray and simply define what it interacts with. For now, I'll just add vehicle. It seems I made a mistake here and used multi-sphere trace. After fixing that, next we'll create several new variables. The first called canChangePath, the second road blocked in middle, and two others for right and left. If there's any interaction detected, that means there's an obstacle on the path and the car should change lanes. Otherwise, the path is clear. Next, we'll copy everything and paste it here. The difference now is that we'll add getRightVector@Distance. Multiply it by 400 for now, and add it to the car's position on the spline. We'll also change the variable here to right. We'll do the same again, but with the value negative and the variable set to left. This way we've created our detection traces, but there's still some work to do. So we'll create another custom event and name it ChangePathLogic. Before changing lanes, we want to check two things: that the variable change path is true and that the speed reaches a certain threshold. I'll leave it at 5 for now. There's a reason for that, which you'll understand at the end of the video. The idea is simple and easy. If the right path is blocked, the car moves toward the middle path. If it's not blocked, it moves toward it directly. And similarly for the middle and left paths. Finally, we'll turn off the change path variable. Now I'll put everything inside the event tick to show you what we did. It's already working. Let me show you what happens when we change the value here. As you can see, the sphere trace now extends farther, which gives a faster and earlier reaction. Reducing it will make the reaction slower. You can even make the right side react slower than the left one, and so on. It all depends on you. I'll leave it at 800 for now. Next, I don't want the sphere trace to start exactly from the car. I want it to start checking just in front of it. To do that, follow these steps. And this variable will define the initial offset distance from the car. We'll do the same for the others as well. Now, as you can see, the sphere trace moves along the path and follows its rotation. This is already successful, but currently the car won't avoid anything yet. Yes, despite all we've done, it still won't avoid anything except for other cars, and that's because we configured it that way. The reason is that if we made it interact with world static, it would treat the track itself as an obstacle to avoid, and trust me, you wouldn't want to see the chaos that would cause. So to solve this, we either give the barriers their own object channel, or we change the object channel of the track and even the landscape. Honestly, I prefer the second option, so let's go ahead and create a new object channel from here. Click on New Object Channel, name it whatever you want, and set it to Block. Next is simple. First, change the object channel of the landscape under the track. Then change it for the track itself using the following steps. This will fix the problem. Now let's add a new object channel here to respond to it, and it will be world static. Let's test it now and see if it avoids the wall in front of it after detecting it. Amazing, it actually avoids it. Let's try again. This time from a closer angle. So yes, that was everything. This system is still in its early stages, and I'll continue improving it by adding more path checks and better car movements. I'll eventually turn it into a plugin on Fab once I develop it further. But for now, I've given you the basic idea of the system so you can use it in your own games in the future. If you enjoyed the content, don't forget to subscribe and take a look at my channel. You'll definitely like it. It's full of new and original ideas, trust me. Thanks for watching until this point.